Today's lesson is on the families on the periodic table, their family names, and their characteristics. The first family on the periodic table is group 1A. That's Roman numeral 1A. These are known as the alkali metals. Alkali. I do want to point out as we start, if you look at your periodic table, you'll see the top of group 1A, there's hydrogen. Hydrogen is not an alkali metal. He really doesn't have a family, as we'll talk about later, but he does fit best in group 1A because of his one electron, which happens to be his valence electron. And remember from yesterday's lesson, the group number indicates your valence electron. So he fits best in group 1A because of that one valence electron. The alkali metals are extremely reactive. In fact, they're the most reactive metal family on the periodic table. Most reactive metal family on the periodic table. They are not found free in nature. They must be stored under kerosene, and that is to keep them away from water because they react violently with water, as we will look at in our review in class. I will show you some video links with the alkali metals reacting with water. Very violent reaction. So they must be stored under oil to keep the water from coming into contact with them. They are silvery in appearance, and they are all soft enough to be cut with a knife. Very soft metals. The group 2A elements are called the alkaline earth metals. And again, this is spelled differently than the first group. The first group was alkali. These are alkaline earth metals. And there's two key words here, alkaline earth. And that's kind of how I remember that's group 2A's name because Roman numeral 2 has two key words. Alkaline earth metals. These are harder, they are more dense, and they're stronger than the alkali metals. They're less reactive than the alkali metals as well. However, they're still too reactive to be found free or pure in nature. You will never find an alkali or an alkaline earth metal free in nature. They will always be combined in a compound and must be isolated through decomposition. Moving on to the next section of the table, which is not just one column, it's a whole section. We call these the transition metals collectively, and they're situated on the table between groups 2A and 3A. These are also known as the B elements. These metals have typical metallic properties, and what I mean by that is they are shiny and ductile and malleable. They're excellent conductors of heat and electricity. The same is true for your alkali and alkaline earth metals as well. However, they're just so reactive that kind of sets them apart. The transition metals are just typical metals. So if you look at your table, you'll find in that section copper and gold, silver, nickel, iron, just to name a few. These are your typical metals. We're going to skip on over to the halogen family. This is group 7A, the halogens. The word halogen means salt former, and it's Latin. And so you all are familiar with NaCl. Well, chlorine is from group 7A, okay? He's the halogen. And when he combines with a 1A or 2A metal, or any metal really, it forms a compound that we collectively call a salt. So the word halogen does mean salt former. These halogens react vigorously with most 1A and 2A metals to form a salt. Another thing I want to add here is that the halogens happen to be your most reactive nonmetal family. The most reactive nonmetal family. These are very unstable, and that's why they react so vigorously. Just like the group 1As are the most reactive metal family, and they react very vigorously as well to try to become stable. Finally, moving over to group 8A, we see the noble gases. Now, this family of elements are very stable. They're the most stable family on the whole periodic table, and that's why you don't typically see them in compounds because they're so stable they don't need to form compounds. They're also known as the inert gases, and inert gases means extreme, or the word inert means extremely stable and unreactive. These are, as I just said, unreactive. Why is it then that the noble gases do not react? Well, the key is they already have 8 electrons in their outermost shell. Now, the exception to that is helium, but Helium does have a full valence shell, so I'll just put here they have a full valence shell. And that makes them very stable. That is the key. All elements want to somehow obtain a full valence shell. The other elements have to bond with each other in order to achieve this. I oftentimes refer to this family as the happy family because they're so stable. They just kind of got it going on. Now, the next section here is about some kind of some exceptions to the general rule, and they pertain to hydrogen and helium. Now, both of these are nonmetals, and they are both colorless, odorless gases. The thing that's different about hydrogen is he has no family. He's the only element on the periodic table that does not have a family. As I said earlier, he is grouped with the 1As because he has one valence electron, and that's just where he fits best. Helium is, in fact, a noble gas, but the thing that's different about him, as I mentioned earlier, is he only has 2 electrons, and that's in his valence shell. And if you remember from yesterday's lesson with the Bohr models, the first shell on any atom can only hold 2 electrons, so it's full. So he is stable because his valence shell is full with just 2. Now, the last two we're going to look at here are really not families. They're what we call series on the periodic table, and they're called the lanthanides and the actinides. The lanthanides are rare earth metals, so they're rare, not very common, and they're rare earth. I just remember that lanthanides kind of sounds like it's got the word land in it, and even though there's no D, and the land is the earth, so rare earth metals. These are elements have the atomic numbers 58 to 71 on the periodic table, and they range from cerium to lutetium. The actinides are all radioactive. So remember, actinized radioactive. That's how you can remember that. That's the characteristic of them you need to know. And their atomic numbers range from 90 to 103, which is thorium through lawrencium. Together, these two rows are referred to as the inner transition metals because if you look at the periodic table and look at the atomic numbers, you will see that the atomic numbers fit within the transition metals. Finally, I do want you to be aware that there were 3 groups of elements that were added to the periodic table later. The noble gases, because they were so stable. I'll put because so stable. So nobody knew they were there because they just weren't forming compounds. They were kind of keeping to themselves. So that's why they were discovered later. The lanthanides, because of what I just said on the last slide, because they were what? Right, they were rare. If they're rare, you don't find it very often. So they're the rare earth metals. And then the actinides were added later because of their radioactivity. That was discovered later. And a radioactive substance goes through a nuclear transmutation. So it changes until it tries to become a stable isotope. So they were radioactive. That's why they were discovered later. And so they were all added to the periodic table later because they were not discovered when the table was first arranged. All right, that's it for this lesson. I'll see you next time.